Hi guys, so in this particular question, we're going to be using modified Newton-Raphson to solve for the root of this equation. I already gotten f bar and f bar, but that's basically the differential and double differential of the initial equation. This in this case, we have been given an initial guess. You can also get initial guesses using bisection method, so you can go and watch the video before this. So, but before we use the modified Newton-Raphson formula, let me use the normal Newton-Raphson and solve this and show you why we need this modified. So for the normal Newton-Raphson, the formula is xn plus 1 equals to xn minus fx of n over f bar x of n, right? So in this case, it's going to be x of n. In this case, is x0. So this x1 equals to x0 minus f x0 f bar x0. So x0 is 0.7. So f of x0, that is f of 0.7. So basically put 0.7 to the x you find here. That's going to give you minus 0.044. And then f bar x of 0 is going to give you what? 0.05. So basically just put 0.1 into this point where you see x. Now when you put it back into the equation, you're going to get x1 equals to 0.7 minus 0.044, right, over 0.05, which is going to give you 1.58. See, this is a very huge jump from our initial get 0.7. So that's why we use modified Newton-Raphson instead. So this is the formula for the modified Newton-Raphson. This is plus or minus. You pick h will either be positive or negative, that's plus minus, depending on if the sign changes when you do this. So fx naught is as f 0.7. Basically put 0.7 to this point, you're going to get minus 0.044. And if you do f bar x naught, that is you put 0.7 into the value here. We did it before, so it becomes what, 1.6. You can see there's a sign change. Here's negative and here's positive. So therefore h in this case will be positive. So we're going to have xn plus h in this case. And this will be equals to 0.05. So you can see here is positive, here is negative, and here is positive. Because there's a sign change, we're going to have positive h instead. So this will just be um plus instead. Now for me personally, I like to solve for h instead. So f of xn, n in this case is what, x naught, so that's f of 0.7. That will be equals to minus 0.044. And then f differentiates twice of x naught, that's 0.7. Put 0.7 into this point, it's going to give you 6 times 0.7 minus 2.6, which is 1.6. So therefore h in this case will be equals to minus 2 times minus 0.044 over what, 1.6, which is going to give you 0.234521. Now put this into equation, it's going to be x1 equals, because it's n is equals to 0 in this case, then x naught will be here, to be x naught. So 0.7 plus what we got there, 0.234521, right? It's going to be equals to 0.93451. So that's going to be our x1. You can see it's a lot more closer to our initial guess of 0.7. Now after we do this, we can now go back to normal Newton-Raphson formula. So in this case, we're going to have, remember what we got last time was x1. So now we're going to be at n equals to 1. So that to be x2 equals to x1 minus f x1 f bar x1. So in order to get f x1, that's 0.93451. That's what we got last, right? That be equals to 0.024625, and second one f bar 0.93451. Just to substitute into this point, it's going to be equals to 0.590233. Therefore, x2 will be equals to 0.934521 minus 0.024625 all over 0.590233. It's going to be equals to what, 0.892801. So now we can now do at n equals to 2, right? That'll be x3 equals to x2 minus fx2 all over f bar x2. Fx2 in this case f 0.892801. We substitute it into this first equation. It will be equals to 0.002544 And the second one is going to be f bar 0 point is going to be equals to, now just substitute into this equation. That is 0.469997. Is substitute into this equation, x2 is this and this, you're going to get 0.887387. Now for the third one, at n equals to 3. So now for n equals to 3 is going to be x4 equals to x3 minus f x3 f bar x3, right? It's still following the same pattern, as you can see. So it's be f x3 in this case was 0.887387. You put this into this equation, you're going to get 0.000040. For f bar, going to be equals to 0.455160. Into the equation is going to be this minus this over this, 0.887298. And now for n equals to 4, for f of x4, that is f of this, is going to be equals to approximately 0. So if this is 0, we already know that it's just going to be x5 equals to 0.887298. Because if here is 0, it makes everything here 0. So no need to waste our time. So this is now equals to 0. As you can see, x4 is now equals to x5. We have reached what we call the point of convergence. So therefore, our final root is this. This is our answer. Thank you for listening, and I hope you really understood. Thank you.